Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation based on the binomial distribution. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos for this PowerPoint. In this PowerPoint, we cover the concept of binomials and practice some examples on binomial distribution. The probability that a child will like a new flavor of toothpaste is 0.80. 3 children are randomly selected. Construct a probability distribution for the number of children in this group that like the new flavored toothpaste. The first thing to ask yourself as you read the problem is this a binomial distribution? And what is the problem asking us to do? It asks us to construct a probability distribution, so we know that we're trying to construct a table with x's and probabilities, and in this case it's a binomial distribution if it meets the 4 characteristics. To be a binomial distribution, it must have a fixed number of trials. Each child is a trial, and we're always looking at groups of 3 children. So we have a fixed number of trials. Trials are independent. Each child's probability of liking the new flavor is not influenced by the other children. Trials are independent. Check. Each trial has 2 outcomes, a success or a failure. Success will be that we like, or that the child likes the new flavored toothpaste. And a failure will be does not like the new flavor. So we have 2 outcomes. Check. Our last characteristic is that the probabilities remain constant for each trial. Each child has the same probability of 0.80 of liking the new flavor. So that checks off the last or 4th characteristic. Since the problem meets the 4 requirements, it is a binomial distribution. Next, we want to fill in our variables. For Mrs. Borlaug, this is a requirement. For the rest of you, it is a very strong suggestion. It will make the problem so much easier and help you with your organization and thought processes. For your binomial, you have N for your number of trials, P for your probability of success, Q the probability of failure, X the number of successes, and you also want to define what your success is. Let's look at your success. What are we looking for? We're looking for that the child, or that how many children in this group likes or like the new flavored toothpaste. So a success is that the child likes the new flavor. Next, what is the value of N, or what is our number of trials? Since we're looking at 3 children at a time, our N is 3. The probability of success is the 0.8. And our probability of failure is 1 minus P, which some of our text and instructors use the 1 minus P instead of Q. This is only a cosmetic difference and does not make a difference in the calculations. Since 1 minus P is 1 minus 0.8, that gives us 0.2. And x is the number of successes. Since n is 3, the number of successes we could have would range from 0 through 3. We now have our variables filled in and can construct a probability distribution for the number of children in this group that like the new flavor of toothpaste. Notice for this problem, the directions follow the word construct. We want a probability distribution, and we have our first technique. We will build our table here, and our technique 1, we will start thinking about the number of kids that will like the toothpaste. And that could be 0 of the children like toothpaste, 1 of the children like toothpaste, 2 like toothpaste, or 3. If none of the children like toothpaste, that would be not like, not like, not like, or n. We'll let n be not liking the toothpaste. If 1 likes the toothpaste, that could be a like followed by 2 not likes, or the other 2 orders there. And I'm not going to read through all of the orders. If 2 like the toothpaste, notice we have 3 options for that, and you see the 3 options that we have. And if all 3 like the toothpaste, we have the 1 option of like. So we have all of these ways that we can have and select the 3 children, and we've just listed all of those ways out. Notice that this would get cumbersome if we had an X, or a number of trials, if we had a number of trials that was larger, but for this problem it's very manageable. Now let's figure out the probability for each of these that are shown. The probability of not liking the toothpaste is the Q. So for 0, that would be 0.2 times 0.2 times 0.2, which would give us, we're not figuring those out. For 1 liking, that would be 0.8, our success, times 0.2 times 0.2, 2 failures. Notice that the other 2 arrangements here are 1 success and 2 failures, just in different orders. In the next set, we have 2 successes and 1 failure, and 2.8s and 1.2 in different orders. And for 3 liking the toothpaste, we have 3 0.8s. We can calculate out the first one and get 0.008. The next set all gives us 0.032. The next set all give us 0.128. And the last one gives us 0.512. Since there are 3 ways that we can have 1 child like, we would want to add those up and get 0.096. The same for 2 children liking the toothpaste, add those up and get 0.384. How many, if x equals 0, what is the probability? Since there's only 1 way, that would be 1 times 0.008, or 0.008. For x equals 1 child liking the toothpaste, notice there are 3 of the 0.032s, so we could multiply 3 times 0.032 and get 0.096. For 2 children liking the toothpaste, there are again 3, in this case of the 0.128s, which gives us the 0.384. And for 3 children, there is one of the 0.512s, which is 0.512. Now, we have a pattern here, and we will need to be able to expand this problem for our future problems. So, notice that the probability is always a count. Notice the numbers in red, multiplied by the same probabilities. Notice the 1, 3, 3, and 1, which are the counts, multiplied by the probabilities that are always the same for each of those. The count, okay, so let's look, let me go back, the count multiplied by the probability. So let's look at we're going to stop here and we'll look at technique 2 in the next video.